Hello everyone, this is Anmol Gera and today we're going to see basically कि अगर हमको एक array दे रखा होता है as an input, array basically level order में दे रखा है हमको, तो उससे हम एक tree कैसे construct करें, like how. So the question basically is that we're going to see today is, if we have an array of size n, then how can we construct a tree from that. So actually, a question, a similar question came in my placement process. I was giving a test of a company, let's say X. So the question was that we have to calculate the sum of left leaves. मतलब in a tree, in a binary tree, we have to calculate the sum of left leaves. Left leaves. So in that question, the input was in the form of an array. And believe it or not, somehow I was not able to build a tree. And yeah, just because of that, but that this particular thing, my offer almost my offer basically got revoked. The company CTC was somewhere around 11 lakhs per annum. The profile was decent, the company was decent, I would say, but yeah. So basically, from basically just because of this particular thing, just because of this particular thing that I was not able to build a tree in that time frame, I could not, get that offer. I just didn't get that offer. Yeah, for your information, the company took like 19 candidates from our college. 19, is a huge number. It was just like a mass recruiter. Okay, so how will we do it? Okay, so we have an array basically of size n with numbers 1 to 5. What do we have to do? We have to build a tree. Yeah, we have to build a tree, binary tree from that. So what we gonna do? Okay, so we have to make a struct node class. Node class मतलब जैसे we have a, let's suppose when we write index, it means that there is a variable of type int, है ना? So just like that, a struct node would be there is a variable with type node. So in future when we'll write this, let's suppose node x. So x type of variable will be formed. X variable will be formed of type node. So it's basically a int, and we are making one ourselves. So yeah. So there's in data, there's node star left, node star right. Basically, there's a data to it, a data variable, and a left and right are null. Left and right are pointers to that, and they are pointing to null. Okay, so now we have to basically make a node like that. We have declare a node class that whenever we'll write node, so something of this will happen. Yeah, so that is it. Now we have to basically allocate a new node every time. So what we can do, so in this, what I have done, I'm basically creating a pointer of type node which is pointing to the new node that I have just made. So simply node star point new node, the node which I have make. My point is a pointer of type node which is pointing to this node. Now the data of that, the data basically of that node is data. Don't confuse it like this. We should give it d instead of that, right? And the two pointers which are pointing to left and right respectively are basically pointing to null. I'll just initialize the pointers and simply return point. Return point basically because point is a pointer of type node which is pointing to this node. Okay, now the simple part comes. Okay, so this was the two functions. One is a node class. Node class is basically like an int. Int is default. We have created similar thing like int by this struct node. And this is basically I'm creating a new node, and I need a pointer which is pointing to that particular node. So this is it. Yeah. Now I have created a function called insert level order, which will give me the pointer. Yeah. So now which will just basically make a tree. The work of this function is to make a tree. We'll pass a, let's say, root node, the size of array, the array, there is basically of data, and the index. And it will basically help us to create a tree. Yeah. Okay, I think I'm clear. Okay, so in this, I've taken a number input in 10 CIN, normal syntax, array, declared an array, taken input as an array, okay, and similarly node star root is insert level order, array root 0 n, array is a root is there 0 n, and in order root. That is something different. Let's just leave it for now. Okay, so let's just come back to this function. Okay, so first of all, if anybody wants to check that out, the code is inspired by Geeks for Geeks. It's not, I know what it is, but it's not mine. First of all, this. Okay, so what I'm doing is from a root node, I'm basically creating. I'm just basically making a tree. So what will happen? I've pointed this to. So I've created a new node. I've called a function called new node, which will basically give me the pointer of this particular node of this particular node with the data value AI. Yeah. So this will give the address to this root, and similarly, for root ka left, we are calling insert level order a root ka left 2i plus 1, because we know in a tree, if we are building a tree, then for a particular node, let's say I, let's say for a particular node I, its children are on 2i plus 1 and 2i plus 2. And now you can ask, what then, why it is 2i plus 1, and it's basically 2i and 2i plus 1, sorry. Why it's, but in this it's basically 2i plus 1 and 2i plus 2, because the indexing is starting from 0. That's one thing. Okay, so if I is less than, basically when we'll call it, so let's suppose our basically index is 1, then it will become 2, then it will become 4, then it will become 8. But 8 is not, 8 is basically is more than the size of the array. So what will happen, so what basically will happen, it will basically, we don't have that element, so we have to make sure that, if we are creating a node, it should be less than n. So this is just a condition check, and simply return root. If there is no, basically if there's no data left for us to do, if I is greater than equal to n, then we just have to return that, which is basically null. Yeah, I think I'm clear in this. Yeah. Yeah, so this is the whole code, I think. And yeah, this was it. If we want to make a linked list similar to this, what we can do, instead of left and right, we can just create, we just like make one function only, like we just need one function, nothing else. That is one thing. Okay, so what I'll do now, I'll attach this code with the code forces problem, which is basically not this problem. I just attached it, so you can see the code if you want to. Obviously it's very self-explanatory, I don't think anyone would need it, but in general, but basically, okay, thank you.